Okay, guys, so we're back here for section 5.6, and we are starting with inequalities in two different triangles, okay? So to start this out, though, we are going to do a continuation of the triangle inequality theorem, all right? And if we just do a quick recap, what that was saying was that any two of the sides of a triangle, if you add them together, it has to be greater than the third side for a triangle to exist, all right? So, quick side conversation. Let's say I have the side lengths of 2, 5, and 4. Okay. To determine if these three side lengths would make a triangle, what you would do is you take the two smaller ones, which is the 2 and the 4, all right, and you add them together. And that sum has to be greater than the third side, all right? So if you added the 2 plus 4 together, you'd get 6. Is 6 greater than 5? Yes, it is. So those three side lengths could make a triangle, all right? But if you had something like, let me delete that real quick. Okay, what if you had the side lengths of 2, 1, and 3? Okay, so if I added the 2 and 1 together, all right, is that greater than 3? No, it's not. It's not greater than 3. That's not true. All right, so then no, that triangle wouldn't exist. Okay, so this one, though, all right, what we're being asked is we're trying to find the range of numbers for the unknown third side so that the triangle would exist, okay? So what we're going to do is for the first example, all right, we're given the two different side lengths, but we don't know what the third side length is, right? So in math, what we do is we assign that a variable. So I'm going to say that that is x, all right? So my three different side lengths are 19, 31, and x. Okay? So what we need to find is a range of numbers so that the triangle would exist. Okay, so let's remember what the triangle inequality theorem said. It said that you could add any two of the side lengths and it has to be greater than the third side. Okay, so let's take a look at, let's do x plus 19. All right, so what the triangle inequality theorem says is if we take those two sides, has to be greater than 31. So we're going to solve now, all right, and we're going to subtract out that 19, and we're going to get x has to be greater than 12. Okay, but we have to do this two more times, all right? So now I'm going to do x plus 31, and that has to be greater than 19, all right? But if we solve this one, I would get x has to be greater than negative 12. Now, there's an issue with that because x has to be greater than negative 12, but that means that x could technically be negative 10 because negative 10 is greater than negative 12. And that doesn't work because you can't have a side length that's negative. So that's not going to work, all right, within our range, okay? Now, for the next one, we're going to take 31 and 19. We're going to add those two together, set that greater than x. All right, so if I add the 31 and the 19 together, I get 50 has to be greater than x, okay? So if I want to write this together, I have my upper and my lower bound, which means my lower bound is 12, and x has to be stuck in between 12 and 50, okay? Now let's just kind of see, all right, how that would work. Let's say I pick a number. Let's say 40, all right, is in between 12 and 50. So let's say my side lengths were 12, 50, sorry, that's not right. All right, let's say my side lengths were 19, 31, and 40. Let's see if that would work. If I add the 19 and the 40, or the 19 and the 31 together, I'd get 50. 50 is greater than 40. That's true. All right. If I added the 31 and the 40 together, I would get that 71 is greater than 19. That's true. All right. If I added the 19 and the 40 together, I would get 59 is greater than 31, which that is true. So in all three cases, the triangle would exist. Okay. Let's try the next one. So the same idea, all right, I'm going to put an x, all right, to represent my third side length. So I would have x, 14, and 15. So I'm going to start off with adding, all right, any two of them together. So I'm going to do x plus 14. That has to be greater than 15. So if I solve that, I get x has to be greater than 1. Okay. Now let's do x plus 15. Has to be greater than 14. But if I solve this one, I get x has to be greater than negative 1. And once again, you could still be dealing with negative numbers. I could have negative 0.5 for my side length, but it's still negative, so that doesn't work. All right? Now, my last one, I'm going to do 15 plus 14. has to be greater than x, which means that 29 has to be greater than x. All right? Which means that x has to be stuck in between 1 and 29. So any value in between those two. Okay? Now, we're not going to do the third one. All right? We are going to do the second one here, or the fourth one here. Okay? This time, though, it's giving you guys an expression, all right, for that third side. Okay? So we're not assigning it x. It's given to us as x plus 1. The process is still the same, though, all right, where I'm going to take any two of the sides, set it greater than the third side. So I'm going to start with x plus 1 plus 5 has to be greater than 7. All right, and if I combine stuff together, I get x plus 6 is greater than 7, which means that x has to be greater than a positive 1. All right, let's try the next one. So this time, let's do x plus 1 plus 7 has to be greater than 5. All right, solving that, I would get x plus 8 is greater than 5, which means that x has to be greater than a negative 3. Now, we need to double check that one, though, all right, because this is an expression, all right? So technically, if x represented, negative 0.5, it would work, but it has to work in every case when x is greater than negative 3. So this one wouldn't work because if I had that x is negative 4, all right, if I plug that back in, I would not get that to be a true statement. All right, so that's not going to be true. Okay, now our last one is if we do 5 plus 7 has to be greater than x plus 1. We get 12 is greater than x plus 1. All right, if I subtract the 1 over, I'm going to get 11 is greater than x. All right, which means that x has to be stuck in between 1 and 11. Okay? All right. Moving on. All right. I'm actually going to pause there, all right, because our next couple ones are kind of lengthy, and I want to make sure that this uploads to YouTube. Okay, so come back for the next two really important theorems.